Hello students. So today we are going to see another topic, that is probability. Although it is an easy topic, but still there are few complex sums or students find it difficult to do. So when I explain, I will focus on those types of questions. So we will see probability. Before I start, my name is Santanu Das and I've been teaching from the last 27 years, and in this video I'll try to make the concept of probability simple and easy for you. Before we start with any sum, there are a few concepts that should be clear in your mind before we start with the sums. So we'll see those things first. That is natural numbers. Natural numbers n. So whenever I say natural number, we start from counting number, that is 1, 2, 3, and it continues till infinity. Whole numbers. Whole numbers, and it is denoted by W. And that's it. We have to include 0 and all the natural numbers 1, 2, 3, and it goes on till infinity. Integers, it will not be needed, so we'll not see it. We are basing our concept only on probability, so whatever will come in the probability, those things we'll see. Even numbers. Even numbers are those which are divisible by 2. It is 2 stable, 2, 4, 6, 8, and it goes on. Odd number. So odd number means not divisible by 2. Not divisible by 2. So 1, 3, 5, 7, and it will go on. You have to remember 0 is neither an even number nor an odd number. Then prime numbers, which comes in own table or one table. One table we didn't write it. Own table, like start from 2. 2 comes in only 2 stable. 3, 5, 7, 11, and it goes on. You should know the prime numbers. Composite numbers, those which are not prime numbers. Not prime. The rest of the numbers, like 4, 6, 2, 3, 4, 6, 8, 9. This come in other tables also other than their own table, so they are called as composite number. Now here you have to remember 1 is neither a prime number, neither prime nor composite. Very important thing. Okay, then yeah, right now we'll see, keep it till here only, and if we come across more important information, we'll write it down. So I have already written 2 questions, so let's accordingly with the explanation of the question, we'll see if anything new comes up. 2 dice are thrown. 2 dice. What is the probability of getting? First question is prime number on each dice and total of 9 or 11. Okay, so in any of the probability sum, the most important thing is to write the sample space. Sample space means the total of the thing that you are writing. Like for example, here let S be the sample space. This would be the standard first step in every question. Let S be the sample space of 2 dice thrown. So what are the elements that will be included in it? 2 dice, as you know, in a dice we can get from 1 to 6. Now 2 dice are thrown, so in both of them 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, On the first one dice is 2, second dice you get a face of 1, 2 2, 2 3, 2 4, 2 5, 2 6, then 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3. I'm taking the complex sums, so this is so lengthy. Most of the time the sums are quite simple. 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, and 5 6. That is, on the first dice it's 5, and the second dice you have this respective numbers, or 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. Now, as you can see, I have written all the possibilities, and this is the most important thing. If you know how to write all the possibilities, then it becomes very simple after that. Now, there are two questions given. The first one is, now that's the event. What is the event we want? Let an event of prime number on each. Let A be the event of prime number on both dice. Now check out which are the possibilities. Prime numbers on both. So you see, one is neither a prime number, so this one we can't take any of them, because in A is the event of prime number on both the dice. So we can't take this ones. We can start from here. 2 1, no. So the first one would be 2 2 or 2 3. Both are prime numbers. 2 4, no, not 2 4, because 4 is not a prime number. 2 5, 2 6, no. 3, not 1. 3 2, 3 3, both are prime numbers. 3 4, no. 3 5, yes. 3 5, 3 6, no. 4 is not a prime number, so none of this. 5 1 is not a prime number. 5 2, 5 3, 4 is not a prime number. 5 5 and 5 6, 6 is not a prime number, and 6, none of them will be, because 6 is not a prime number. So these are the number of elements. So in this one, if you count, the total number of elements in the sample space was 36, and here the total number of events is 1 2 3 4 5 6 7 8 9. So NA is 9. So the probability, now here a very common mistake which many students do, they write the sample space at the top and the event space down in the denominator, which is wrong. The event is always written up and the sample space is written down. It's just like calculating a percentage. Whatever your marks, you write it up, and the total marks you write it down. So same way, probability is percentage. So basically you have to write the total always down, and whatever the event you are talking about, that's going to be up. So it's 9 upon 36. So 9 ones are 9 fours are. So 1 upon 4. Probability of a prime number on each dice is going to be 1 upon 4. Don't forget to write the conclusion. So that's the answer of the first question. Second question is total of 9 or 11. Now again a new event, let be the event of total 9 or 11. So let's write it down. The total is 9. So total is 9. This is not possible. 2 6 is 8. 3 5, yeah. Let's start from here. You see 3 plus 6 is 9. So this possibility, 3 6 is 9. 4 5 is 9. 5 4 is 9. The total is 9. And 6 3 will be 9. So these are the possibilities where the total of the two dice, when we add it, it's 9 and or 11. 11, the total is 11. So can't take these numbers because the total will be less than 11. Here we get the first one. 5 6 is going to be 11, and 6 5 is going to be 11. So therefore, number of elements in B, count it, 1, 2, 3, 4, 5, 6. 6 elements. Therefore, probability of B would be again NB upon NS, total event upon the sample space. So event is 6, sample space is 36. So the answer is going to be 1 upon 6. So this is how we calculate the probability. Okay, let's see one more question. Now 3 coins tossed. Okay, now this is again a very important question. Coins tossed. Okay, so in case of coins tossed, okay, so there's a formula that you need to know, that is 2 raised to n, where n stands for number of coins. So if you toss 2 coins, so that is going to be 2 raised to 2, that is 4 possibilities. 4 possibilities. Now in this case there are 3 coins tossed, so that means 2 raised to 3, that is going to be 2 raised to 3 is going to be 8 possibilities. Now how do you write those possibilities? Take the half of 8. Half of 8 is going to be 4 heads, 4 tails, 2, 3, 4. Now half of 4 is 2, so again 2 head, 2 tail, 2 head, 2 tail, and half of 2 is 1, so it's going to be head, tail, head, tail, head, tail, head, tail. So these are the sample space. This is going to be the sample space. So the sample space is, first always we write on the sample space. So let S be the sample space of 3 coins tossed. So let's write down all the possibilities. Head, 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 comma, head, head, tail, head, tail, head, third one is head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So these are the possibilities. Tail, tail, tail. So total number of in the sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8. Now what's the first event? Let A be the event. What is our first question? Of at least 2 heads. At least. Now this is a very, very important word, because students always make a mistake on this. At least means that value and more than that value. Okay, so like for example, in the exam you say that it was a 50 marks exams, and you say I will get at least 40 marks. So what you mean by that is you will get 40, you'll get 50, 49, 48 till 40. At least you will get 40, not less than that. So whenever you see the word at least, you have to take that value and the values more than that, not less than that. Okay, so 2 heads at the maximum, there are 3 heads. So 2 heads, when I say be the event at least 2 heads, means there can be 2 heads or 3 heads. Okay, so you have to take the other way around, that is the maximum one. So A would be 2 heads or 3 heads. Look for it, 2 heads. Which is 2 heads? Head, head, tail, head, tail, head. This one is only 1 head, tail, head, head. This is 1 head, this is 1 head, this is no head, this one, or 3 heads. This, so this will be the possibilities. 2 heads, these are the possibilities of 3 heads, 2 heads or 3 heads is this one. So number of events is going to be 4. Therefore probability is going to be Na upon Ns, that is going to be 4 upon 8, that is 1 upon 2. So that's going to be the first one answer. The second one, you can denote it with any letter and continue. Let B be the event of at the most 2 heads. At the most 2 heads. So when I say at the most, I mean to say that value and going back. That is, again, continuing with our example. Suppose I say I'll get at the most 40 marks in the exams out of 50. I mean, you go back means 40, 39, 38 till now. Here students make a mistake, they take it till 1. It's not till 1, you have to take the 0 value also. Okay, so that is the mistake which is done. So when you say at the most, that value and the value is less than that, that is 2, 1, and don't stop at 1, and 0 also have to be taken. So you have to take 2 heads or 1 head or 0 head. So which will be coming in that is 2 heads. 2 heads is head, head, tail, head, tail, head, tail, head, head. This pair of 2 heads. 1 head is this one, H. You have to just look into the sample space. Head, tail, tail, then tail, head, tail, and tail, tail, head. These are of 2 heads, and 0 heads means no head. This is this one, T, T, T. So number of elements in B is going to be equal to 1, 2, 3, 4, 5, 6, 7. So 7. Therefore, probability of B would be NB upon NS. That is going to be 7 upon 8. And last but not the least, the third one was 2 tails. Let C be the event of 2 tails. Now it is neither at least, neither at the most, exactly the value. So whenever there is the exact value, so you have to just take those exact values. So which are the exact values? 2 tails. Where are 2 tails? This is an example of head, tail, tail, and head, tail, tail, then tail, head, tail, then tail, tail, head. These are the examples of exactly 2 tails. So neither you will take more than that, neither you will take less than that, because here they want exactly that many, not at least, not at the most. Once more, quickly I'll revise. At least means you will take that number, whichever the number, and bigger than that till the maximum possible values. When it's at the most, then whatever the value they have given, and go back till 0. Okay, and when it's exactly, so you take exactly that many. So 2 tails. Therefore, NC is going to be equal to, there are 3 elements. Therefore, probability of C will be NC upon NS. That is 3 upon 8. The probability would be 3 upon 8. So we'll take one more example. A card is drawn at random from a pack of 52. Find probability that the card chosen A, it's a king. B, it's a face card. C, a black card. So quickly we'll revise this and then we'll start. See, in a pack of cards, as you may be knowing, there is diamond, which is a red color. Then there is this hearts, which is also red color cards. Then there is this clubs, which is black color cards. And then there's this spade, which is also black color card. That's the first thing. Now face cards, what are called as face cards? Face cards are J, Q and K. Now in every pack, in each of them there are, in diamond you will have jack, queen and king. In this also. So overall 3 cards in each of this. So total there will be 3 into 4, 12 cards of face. Okay, and ace card, A is called as ace card. So again, there are 4 ace cards. A means actually 1, so there are 4. So this is the most important thing that you should know, and then the sums are quite easy. Solution: let S be the sample space. S be the sample space of a card chosen from a well shuffled pack. Now here you don't need to write down all of them 52. You can directly write, as there are 52 cards, so it's going to be NS is going to be 52. All the possibilities is going to be total 52 cards. Now first event is, let A be the event of card chosen is king. Now king, that is K. So this is called as king, this is queen, and this is jack. So king, there are 4 kings in the 4 colors. So let A be the, so how many? You don't have to draw them, you can directly write Na is equal to 4. Therefore the probability would be Na upon Ns, that is 4 upon 52, that is 1 upon 13. So the probability would be 1 upon 13. So that's the first question. Second question, a face card. Let B be the event. Let B be the event of a face card chosen. Face card chosen. So face cards. These are the face cards. In each of them 3. So total there are 12. That is 12 face cards. Therefore, you will write NB would be equal to 12. Therefore, probability of B would be equal to NB, number of elements in B upon number of sample space. So that is going to be 12 upon 36. 12 ones are 12 threes. The answer is going to be 1 upon 3. Third one, let C be the event of a black card chosen. Black card. So C, that is black card. How many clubs is black and spade is black? So in each of them there are 13 cards. 13 cards plus 13 cards. I'm sure you people have seen a pack of cards, 13 cards. So total there are 52 cards in a pack. So black cards are 13 clubs, 13 spade, that is 26 cards. Therefore, NC is going to be equal to 26. Therefore, probability, we need to calculate the probability. So that's going to be NC upon NS. That is going to be 26 upon 52. That will come to 1 upon 2. So that's how it has to be done. Okay, I remember a sum now. Quite a common question. So we'll see that sum also. The sum is, find probability of 53 Sundays in a leap year. Now how to calculate it? First of all, solution. Let S be the sample space of the days in a leap year, of the weekdays in a leap year. Now, very important thing, in a normal year, there are 365 days, that is 52 weeks plus 1 day. And in case of a leap year, there is 366 days. That means 52 weeks plus 2 days, 2 extra days. 2 extra days. So now let S be the sample space of the weekdays in a leap year let S be the sample space of the extra days in a leap year. So what is the possibility? So what would be the possibility, as there are 2 extra days? So those will be either Sunday and Monday, because 2 extra days. So those 2 extra days will be Sunday or Monday, or Monday and Tuesday, or Tuesday and Wednesday, or Wednesday and Thursday, or Thursday and Friday, or Friday and Saturday, or Saturday and Sunday. So these are those extra days. These are the possibilities. They will be either a Sunday. This will be the possibility. So how many possibilities? 1, 2, 3, 4, 5, 6, 7. So NS is 7. Now they have asked us to find out the probability of 53 Sundays. Means normal in a year there are 52. 52 weeks means 52 Sundays. But 53 Sundays means those 2 extra days should be Sunday or Monday, or Saturday and Sunday. So let A be the event of that extra day being a Sunday. So those possibilities are, see in the sample space, this one Sunday and Monday, or Saturday and Sunday. So the number of events is going to be 2. The probability of getting 53 Sundays is going to be Na upon Ns, that is 2 upon 7. Okay. Now this question I've seen in the exams, they asking you question, find probability of 53 Sundays in a year. They don't mention leap year, just in a normal year. So if that question was asked, in that case, they are not asking for a leap year. So that means there will be 1 extra day. Then the sample space you would have just written, it's that extra day will either be a Sunday or a Monday or a Tuesday or a Wednesday or a Thursday or a Friday or Saturday. And your event will be 53 Sundays, means that extra day should be a Sunday. So you will take that possibility Sunday. So then the answer would have come as 1 upon 7. So these are the tricky questions in probability and which students fear of. I hope you have understood this, and now you'll be able to do these sums also. And any doubt you can ask me in the comment section, and do share with your friends and everyone who find maths difficult if this video is of any help to you. Thank you for watching the video.